and namaste everyone. I hope all of you are doing well. So today I am going to talk about warbots with a brain, AI into the arena. But before we start, let me just give a small introduction about me. I am Manesh and software engineer who works at BBD, which is located in India. And today is a bit special day for me, not just because I'm standing here all the way from India to talk about something which I'm deeply passionate, but it's a special day for me because I just completed my 3 years in BBD. Yes, literally today. And yes, for the past 3 years, I've been working on fixing the bugs, writing codes, solving real life problems, and all the duties which the software engineer does. But once I shut my laptop, I switched the gear. And for the past 2 years, I have been working on building these bots. Not because it is my work, but I build them just because I love to build them. I love to see these hunks of metal that I build come into life when you keep them inside an arena. Sometimes you win, but sometimes you lose. But either way, it's a glorious thing to watch them fighting. And one thing that kept bothering me, like these bots are there, right? All their power, all their controls, they all are controlled by us. Like when to charge, when to dodge. They listen our signal, they receive it, and they act how we tell them to act. And that got me thinking, what if we start giving brains to these bots? Yes, I'm talking about getting AI into the picture. And with that, we will step into a space where the line between the science fiction and the reality is blurring out. And let me tell you, it's not happening somewhere deep inside a space or into the Silicon Valleys. It is happening inside the enclosed metal cage surrounded by the cheering crowds where the robots fight. Welcome to the world of robowar competitions, where metal meets sparks, strategy meets chaos, and sometimes we'll just flies off in the middle of the match, wherein the builder of the board stand frozen, smiling outside, crying inside, and months of effort turn into scraps within few seconds. And honestly, it feels less like engineering, more like my last relationship. Build with love, destroy in no time. But hey, let's keep the heartbreak side. And today I'm going to talk about the exciting world of AI power warbot, wherein you will explore how AI is transforming the way the warbots fight, from real-time opponent tracking to uh, adaptive attack strategies and the autonomous survival. But yes, let me just be honest with you. We are not there yet. We don't have a fully AI power warbot ready yet. But the idea is still under progress. And sooner or later, we will definitely have a warbot which will be controlled by AI. Now, let's just start ask a small question. How many of you have heard about these battle bots or how the robo competition works before I started my talk? Cool. Okay, that's nice. So, let me tell you, the warbots are nothing but these are these small mobile combat machines that are designed specifically for head-to-head competitions inside an enclosed arena. So, with that, I would like to share how I started my journey of building these warbots, and you can start too. The first important thing to build a bot is to decide what kind of bot do you want to build, because these bots are usually categorized based on the attacking strategies. So we have something known as a spinner bot. These bots just have a high spinning weapon attached to its body, which deals with the damage of your opponent. The other one is the most simple one. It just has a flipping hand in front of it, and it just launches the opponent high in the air, which let you win the match. Yes, of course. How can you forget the most notorious one? As you can clearly see, this bot doesn't have any attacking weapon, right? So this bot totally relies on the high producing torque, and it just moves very quickly and fastly inside the arena, confuses the opponent, and due to its wedge design, it just pushes the opponent towards the wall. And the other one, we just give an overhead strikes to your opponent, known as the hammer bot. But yes, now you have decided what kind of bot you want to design, right? Or we want to build. Then comes the real building process of the bot. You have to design your bot. And to design your bot, you can use any 3D design software which are widely available in the market, such as like AutoCAD, Fusion 360, SolidWorks, or any other thing. But here is a catch. Just by designing, we can't build a bot. because we are no magician. We just can't say abracadabra and a bot will be ready, right? Because to build a bot, we need to maintain the balance between the four main components. The first one we have is the drive system, also known as the mobility of the bot. The drive system is what keeps your bot moving across the arena quickly, smoothly, and hopefully under control. Okay, drive system is nothing, but it just includes the motors and the wheels. This together makes the drive system of your board. Now, let me tell you, the mobility of the board is very important because it determines how well it can evade the attack or line up on its own. And mobility is just like a footwork in boxing, most underrated but game changing. Then we have the most flashy part of any bot, known as the weapon system. The weapon system is the most offensive part of the battle bot that you will build because it helps to disable your opponent completely, of course, in legal ways. Okay? And if you design your weapon in a right way, then you can even win the match within few seconds. Then comes the defense system, the third component. Defense system is just as critical as the weapon system because defense system is what keeps your bot alive and it keeps your bot alive into the arena. You should build your defense system in a such a way that you should be able to take the hits from the opponent during the match. Now, yes, you might be thinking like what material should be used to build a bot. So to build a bot, you could use the mixture of steel, aluminum, titanium, or any other material which you feel uh, is the right for you. And yes, while designing and while building the defense system of the bot, you have to design in a such a way that you should be able to replace the parts of the bot or the components which are there inside the bots very quickly and very easily during the match if any of the component gets fails. Then comes the most important part of any war bot, the control electronics, also known as the brain of the battle bot. Control electronics are nothing but these are all the electronics which are required to give life to your bot, such as we have the receiver and the transmitter. I guess most of the people are familiar with receiver and transmitter, right? So receiver is what just receives the signal which is sent by the transmitter. And the transmitter can be a dual stick joystick controller or a single stick joystick controller. Then the second element component which we have is the one which controls the speed of your motor, also known as the ESCs, electronic speed controller. Then this is the very important system in the building a battle bot because the fail system is what turns stops your bot during the match if you lose signal to your bot, and it just prevents from any other damage to happen during the match. And of course, how can we forget the batteries which will just route the power to your bot. Now over here I have a recently built bot which I have built for the demo, which will be running after a couple of slides. Just to show you, these are the what known as the drive system, the motors and the wheels, and the ESCs which I was talking about are these. I hope it's visible. So this is what controls the speed of your motors during the match, and of course we do have a receiver, and the control is over here, right here. Okay. And yes, of course the batteries. But now the question is, we have got a fully battle build machine ready, right? But what happens when you keep them inside an arena facing another equally powerful machine? And that brings us to the next part of our journey, how the RoboWar competition works. This RoboWar competition basically works in a tournament style or a double elimination style. And these matches are usually played inside an enclosed arena surrounded by the bulletproof glasses, just for the safety purpose. Over here, the winner of the competition is decided by the knockout system. So basically, you have to just disable your opponent bot completely. Now, let me tell you, RoboWar competitions are not just about having the biggest weapon. It's all about using your bot smartly. And to show you what I mean, I will just have a quick demo of this bot which I have built. Let me just connect the batteries.
Welcome to OpenTX. Throttle warning. Switch warning.
You can just ignore all the warnings. It's fine. It's completely fine. Okay, it's working. So let me tell you, this is a manual control board, which means the challenge is not just to build it, but also to learn how to drive it strategically. I hope I can drive it. Okay, so this is how you have to move your bot inside the arena, and which will dodge the enemy. And if you can't attack, then you have to just run away from the enemy, which is the one of the best attacking strategies you can ever have. Okay. Uh-oh. And this is what I call a victory dance. Okay. So now we just have a look at the manual control bot, right? Yes, this is a weapon system which I have built. It's a spinner bot. I have not activated it just because of the safety purpose. But but when you add this weapon, when you add the real sparks into the arena, when you add the metals fighting with each other, the things get really intense. And to give you the taste of the intensity, let's just watch a clip from a real robowar competition. Sorry, let me just play again. So this is how you have to totally disable your opponent. Of course, the winner bot is our bot. This was a real match which we played a couple of months ago. Okay. So now you just saw the victory isn't just about brute force. It's all about perception, control, and most importantly, decision making. Now, traditionally, all these decisions like when to charge, when to dodge, when to strike, all these decisions were made by just one person, known as the driver of the bot. But that raises a powerful question. What if those bots could make those decisions on their own? There comes the AI into the picture, and that is what we will explore next. We will see how AI is transforming the RoboWar competition from test of metal to test of mental. Now, I guess everyone knows what is AI, right? So AI is nothing but it is also a science of making machines to think and act just like us human. It allows the system to analyze the data, recognize the pattern, make the decisions, and even learn from their mistakes, just like us, I hope. Okay. But AI in BattleBot isn't just about using ChatGPT or a DeepSeek or a co-pilot on the wheels. As I mentioned earlier, it's all about perception, decision making, and the control. And there are many different approaches of using AI to build a BattleBot, but the goal remains the same: giving the machine the ability to think, adapt, and act with a purpose. It means that the Warbot can do more than just following the joystick commands. It can react to threat, choose the target, navigate the arena, and even learn from the previous match. Yeah, now you might be thinking, right? If it's not about chat GPT on a wheels, then how do we implement the AI in the Warbot? So the first step to implement artificial intelligence in a battle bot is that we need to give this bot the ability to see the surrounding. And that is what we call the perception layer. In this layer, the bot collects the data from the surrounding using the sensors, such as like camera. I'm not talking about the CCTV cameras which you find in the rooms or the some other places. I'm talking about the small cameras which are available, such as we have Raspberry Pi Cam V2 or even a Logitech USB camera can be used. And the importance over here of using this camera while building the AI battle bot is that the using cameras is the only way which gives the bot the vision to identify the opponent's orientation, position, and the intent. But here is a technical challenge of using these cameras. And these matches are played in a real time. So we required a high frames per second cameras, usually 60 to 120 FPS frames camera to read all the data from the surrounding. And yes, the lightning in the arena may also cause the glare on the camera, which may give the false reading to the camera. Then we have something known as the ultrasonic sensor. It is a device which are basically used to detect the distance between the object or the find the presence of an object inside the arena. The working principle is very simple. It emits the sound pulse and then listen it back, reflect and listen the reflection of the sound of an object. And the distance is just calculated by speed of sound divided multiplied by the echo time divided by the 2. Now, usually these ultrasonic sensors uses the high frequency sound wave, basically like above the human hearing range, maybe about 40 kilohertz. Now, these sensors are basically used to detect the object between for the short distance of to detect the object from the distance 2 centimeter to 4 meters. Now, these sensors are basically used to detect the small trains, right? So we can use these sensors to mount that all to all the side of the board, which gives bot a 360-degree awareness of the arena. But here also we have a technical issue. These matches are played inside a metal cage, right? Of course, the sound will echo and which will affect the reading of the sensors. Then the another sensor which gives the vision for a bot is using the IR sensor, also known as the infrared sensor. These sensors are nothing but it works similarly to the ultrasonic sensor, but the only difference over here is instead of the sound wave, these sensors use the infrared radiation to detect its reflection of an object. So as you can see, these sensors has two LEDs, right? One is for IR LED transmitter, which sends the IR light and which is then reflected of an object, and it is detected by the IR photodiode receiver. Then the intensity of the reflected light is used to convert into a voltage signal, which indicates the presence or the distance of the object. The advantage of using this is like it is very cheap and fast compared to the cameras and the ultrasonic sensor. But this also comes with a limitation that the reflected surface from in the arena or the overhead light can affect the reading of the sensors. Then finally, we have IMU, Inertial Measurement Unit. This is a device which measures the bot's acceleration, angular velocity, and the orientation using the accelerometer or the gyroscope meter, which using the accelerometer or the gyroscope meter. And these sensors are very crucial in AI bot because it detects when the bot flips over during the match or the bot gets the impact from the opponent during the match. Now, after reading all the data, the AI needs to process them, right? That is what we call it the processing layer. Over here, the raw data is converted into the structural information. In robowar competition, every millisecond matters, okay? And the processing must be done at a very low latency. So the processing should have the multi-threaded, like one thread for the sensor to read the data, one thread to for the AI interface, and the one thread for the motor control. Now to build this processing layer, we can use the hardware such as like the microcontroller hardware, which are widely available in the market. We have the Arduino or the ESP32. These are the two microcontrollers which are available in the market, which can be used to do the processing. These microcontrollers used to handle the low-level tasks, such as like reading the data from the IR sensors or the ultrasonic sensor. These sensors are very low powered, but they can't run AI logic. We are coming over there. Okay. So to run this AI logic, we can use the single board computers which are available, such as like Raspberry Pi 4 or a Jetson Nano, which is provided by the famous company NVIDIA. We can make use of these sensors, these single board computers, which runs the very high processing AI algorithms, such as like computer vision or path planning algorithm. The good thing about this single board computer are they support Linux OS and TensorFlow, which helps to build the AI logic very easily. But the only reason of this is like they consume very high power and they can lag if it is overloaded. So the best approach to implement the processing layer in a AI powered battle bot is using both of them together. The Arduino handling the motor and the sensors, and the Raspberry Pi which handles the AI interface. Now, as I just told earlier, right, they all have limitations. They might get affected by sound, dust, or light from the surrounding during the match. So basically, to achieve the more accuracy of the reading of this data, we can use the data fusion algorithms. So now the data fusion algorithm is nothing, but it is what collects the data from the two or more sensors, combine them together, and give us the most accurate information for the processing. Now, then comes the decision making layer. This is the where the heart of the AI bot lies. In decision making layer, the bot makes the strategies. Sorry, that was my controller. I just forgot. Oh, fuck. Sorry.
Inactivity alarm.
Sorry for the. Or it might just catch fire. Sorry for that. Okay. So, okay, yeah. The next comes the decision making layer. This is where the bot makes the strategies in the. This is where the bot makes the strategies in the real time. So, at the simplest level, we can make the use of. Sorry. So at the simplest level, we can make use of the rule-based AI. For example, like if we have the enemy within the range of 30 centimeter, then attack. Otherwise, just continue patrolling. But this approach, as you can see, it is very simple and reliable. But it has a clear weakness. It is predictable. And once your opponent predicts your rule, then they can exploit them very easily. So to overcome that, we can move towards the machine learning based AI. Instead of the fixed rules, the bot can actually learn the strategies from the experience. And with the reinforcement learning, we can let our bot train in the simulated environment, such as like Gazebo or the Python bullet, which we have to train the bots in the real time, in the virtual machines. Okay. Now we can train our bot using these thousands of virtual battle, wherein it tries for different moves, get the feedback, and start learning gradually. And finally, the action layer takes over, executing those decisions with precise motor control, weapon activation, and rapid defensive maneuver. But over here, let me tell you, AI in a battle bot isn't just one move, right? It is not just one time decision, it is a continuous loop. And that brings us to the AI battle loop. So, firstly, the sensor sends the data, then it interprets all the data which is collected from the sensor, then make the decisions, and finally act all in one. And these loops run more than 100 times per second, making your battle bot not just reactive but intelligent. But yes, as I told at the starting of the talk, we don't have an AI battle bot ready. And it's not that easy to build a battle bot because just by wiring up some smart hardware isn't enough, right? Okay. Because as we dive deeper into AI driven battle bot, we quickly realize that building intelligence is far more difficult than just building the armor. Because someone said, with great AI comes the great responsibility. Building an AI battle bot might be just exciting, but it comes with several limitations that makes us far more challenging than just building these traditional bots. The first hurdle which we have is the hardware constraint. This advanced AI model, especially using the computer visions, demand more power, and the more powerful processors are required to run all this AI logic. Yet, these battle bots are small in size and have limited space for all the boards which is available in the market. They have the limited size for the cooling and the wiring to build this bot. Then comes the power consumption. Since running this camera, sensors, motors, and AI logic all together requires a lot of power and battery drains very quickly. And balancing the intelligence with battery life is a constant trade off. And the major challenge is over here is the real time processing. As we just saw in the previous match, the battlefield doesn't wait for anyone. So our AI powered battlebot must collect the data from the surrounding, make the decisions, and act. All must happen in within few seconds. And on top of that, sensor reliability is a constant risk. Dust, vibration, sudden shocks in the arena can make those sensors fail and leave your bot half blind. And of course, building an AI requires more money, more complexity are there, and requires more training, right? So that remains on the top of all the challenges. But yes, as with any innovation, today's challenge become of tomorrow's breakthrough. What seems to be a limitation now maybe just be a something stepping stone towards a far more advanced. But when we look ahead, the future of the AI in BattleBot is not just promising, but it's game changing. AI in BattleBot now isn't just about who wins the match. It's all about the lesson that we learn from building them. So, next time, whenever you see a robot fighting in a cage, sparks flying, wheels spinning, don't just stand there and watch the destruction. Watch the decisions that has been made, because that's where the real battle is happening. Because in the arena of the future, it's not just about the strongest bot that wins, it's about the smartest bot that wins. So now, the robo wars aren't just about raw metal colliding in the arena anymore. they are they are about how much intelligence we can build into these machines by layering the AI's decision making, detection, and the adaptability and the defense. We give our bot the ability to sense, to respond, and to survive autonomously. But here's the important thing: competitive AI design isn't about replacing human skills, it's about amplifying them. The competitive AI design challenges us to design the system where where the human creativity sets the vision and machine handles the split second execution. The blend is where the real edges lies, in the space between the control and the autonomy, between the instincts and the adaptation. It is the future of the robo war is written, and it is written by the team or the people which are bold enough to make their machine not just stronger but smarter. Now, the warbot or the battlebot competitions might be just one arena. Your battlefield may be different, but the need to think smarter, adapt faster, and compete better remains the same. Thank you. Dhanyavad.
Hi, testing. Hi, Manesh.
Hi, Andrew.
All right. So, as we've demonstrated a couple of times, your robot kind of kind of did its own thing for a while there, and I've seen enough movies to know that a robot with a weapon and intelligence doesn't usually end well. So, I guess my question here is. Any guardrails for any of these robots regarding attacking humans and stuff like that? Yeah, that in terms of regulations around the whole building of these AI and things, or is it the industry is so new that stuff like that doesn't exist yet?
Yeah, we do have a bots like with the humans as which have like they to the autonomous and everything. But as of now, we don't have a small mobile combat machines which have the ability to fight on their own because of the many of the constraints. Like they should be like small in size. The weight category also matters. Like we should make these bots like within 1 kg or 5 kg. The weight category also. So that makes us more challenging to build all these bots using the AI and even the yeah, I mean, I say that there are like bots which play football on their own. I have seen the videos, okay, and the bots which flip on their own and everything. But as of now, we don't have a battle bot which just fights on your own inside an enclosed arena. So maybe if we build a one, and if any team builds a one, then we can even start a new category of the RoboWar competitions, where instead of the remote control, we can have the competitions only for the autonomous bot. So yeah, that can also be done in future, but the process is still in the the idea is still in the progress. So we don't have a battle bot ready yet. Any more questions? Yeah, for the manual control, we do have a weight categories. Like it should be 1.5 kg, 8 kg, then 15 kg. We do have for 30 kg as well. And about 30 kg, there are few teams which make like 50 kg. So as of I know, like 50 kg, I have seen the match, but I heard that there are 120 kg bots also which has been built in the robo competition. But that's not that's to build a 120 kg, it's required a lot of money. So usually usually, and as you see, this is a just a 3D printed bot. Okay, so and I didn't bought a real metal one just for the security purpose because I came from India. Still, they stopped me all the three airports just to asking me like, what is this? What is that? Like, bro, it's 3D printed. So yeah, they were just worried about the remote control. They just thought like I'm someone of the undercover. Yes, so yeah. So yeah, the weight category matters. The size doesn't matter. Whether you build this big bot like for 1 kg or you make this small for 1 kg, that doesn't matter. Yep. Yep. So,
Yeah, I'm just keen on what your setup looks like at home. Obviously, to print this, you need your own 3D printers. Do you have any other machinery like laser printers? What else are you using?
so I do have a 3D printer for I have Ender 3v3, the one which I bought 2 years back, which works totally fine for me. Now I'm trying to buy a new one. So I have a 3D printer setup, and for the laser cutting and all the water cutting, this thing, we have a different industries in Goa itself, like in India. So we just send them the STL file of the board, and they just do the printing and everything. So this is just homemade board like which I build. But usually for the competitions, we just send them the design. Like we usually send in Pune. So they have a factory over there. Then they just do the laser cutting and everything. They just courier to my place. And yeah, if anyone wants to, drive this board, you can come and meet me. I will be just around here the whole day until the battery lasts. You can just drive it. Okay. I do have a charger, but it takes 3 hours to charge. Because it's 3000 mAh battery. Yep. Any questions? Yep.
So, what is the kind of cost that you've incurred in this hobby or endeavor?
So let me just get started with this small one, which it took me like around. Can someone open the calculator and calculate into USD or rands, please? Like around 15 to 20,000 INR, which should be around 4,000 rands for this small bot. And the most expensive thing is the controller and the receiver of this bot. It's equal to the whole cost which I took to build this bot. Yeah. Yes, 4,000, right? Yeah. So I'm good at maths. Cool.
Hi there, Manesh. Hope you're well. We've had it's me.
Hi.
We've had battle bots and robot wars for a long time now, many years, decades. Over that time, which bots have made the biggest lasting impression on you? What were your bot heroes?
You mean to like which design?
Like the tombstones, the razors.
Sorry?
Like the tombstones, the razors, these different bots that we see fighting in Las Vegas. Are there any of those hero bots that you've admired over the years?
No, I'm not aware about the bots with the lasers, but I'm not aware about the one which has the flamethrower. But in India, it's not permitted to build a bot for the flamethrower. But anyways, we tried it, but it was not successful. It just caught fire on its own. So that was a total failure. And if anyone wants to see the videos or anything, you can come please meet me. I have a whole folder for the robowar competitions. I can just show you some clips. Yes.
Okay, so yeah, back
Hi
again.
again.
Okay, so obviously this is not a cheap thing to kind of do. So when you get into a match and you lose, like I saw one there which looked like it was broken into pieces. Do I get some kind of compensation or?
No. It's either you just watch your bot getting destroyed completely or just do the tap out if you want to save your money. That's the only two ways where you can save your money. Like, and there is one thing which we were playing one match. So basically, like, this is how we control, right? And I don't know, for some reason the control got swiped and flipped. So we have to play the match like this. Like literally like this. We were playing the match like this, just rotating the control and we just played the match. That all happens in the the real matches. This all electronics are not trustable. Yeah. Any more questions? Yep. So anyone wants to drive, then come and meet me outside the cinema hall. You can drive this board under my instruction. Thank you.